Hello, this is a video on how to determine what are called oxidation reduction reactions. By this time, you should have opened up this web page, also a web page. So these are the general notes. Then a page on directions on how to do these, and a handout on an example of the work that you do. Now, what I'm going to talk about now is a continuation of the oxidation numbers. As I told you before, when you watch the assigning oxidation number video, this whole system is designed to account for electrons moving, because in a chemical reaction, as you know, base particles come in grouped together in a certain way due to the movement of electrons, and they come out in a different grouping due to moving electrons. And the, and the rule is that you must have a conservation of movement of electrons. So besides mass and total number of atoms and total number of each individual atoms, you also have to have a movement of electron conservation in the chemical reaction. So you're going to have to assign oxidation numbers to every single species. And the reason why you do that is because then you're going to compare the oxidation number of the species as if is in the reactant form and compare it to the product form to see if that species is gaining or losing electrons and eventually how many. The rules are, this is not the directions. The rules are that only one thing can lose electrons and one thing can gain electrons. And there's a memorization tool called Leo the Lion Goes Grr, because Leo stands for if the substance loses electrons. Sorry about that. If the substance loses electrons, it's called oxidation. That substance would be called the oxidized element or substance. Okay, it loses electrons. GR stands for gaining electrons is reduction. So the substances that gain electrons are considered being reduced. The interesting thing is the fact that when we talk about these substances being oxidized, substances being reduced, and then the other part is there are actually agents that help things being oxidized and reduced, called oxidizing agents and reducing agents. And all of these substances actually are on the reactant side. So when we go and explain the directions, we're going to define what's being oxidized, what's being reduced, who's the oxidizing agent, who's the reducing agent. And the big picture thing is you got to realize all those answers are on the reactant side. We don't talk about the product sides when we define who's oxidized, reduced, oxidizing agent, or reducing agent.
Good morning one more time. Looks like we're pretty good on our traffic. Teachers, faculty, if you would just pop your head out your door, because there are a few kids hanging out or trying to get through. They're at their lockers. So if you could just look out your door before you do your final posting, I would appreciate it. But other than that, I think we're all set. Thank you very much.
Sorry.
Enjoy your day here.
Sorry about that. So how do you actually determine these four things? That's what the directions are for. So what you do is you have to be given this particular type of determination of what's being oxidized, reduced, reducing agent, oxidizing agent is done by what is called oxidation number. There is another way of doing it called half cell reaction. We are not going to do a half cell reaction analysis. If you take AP chemistry, we usually do it then. So this is designed just from oxidation numbers. So the first thing you need is a complete chemical reaction. So in the example, I give you one. That's what this is right here. Okay. When you do these, you want you want to put some space on top and below the chemical reaction. Okay. So the first thing you do is you determine the oxidation number of all the materials. So again, if you look here, that's an element. Okay, what I usually do is I usually write the things that just simply elements. So that's an element, 0 oxidation. That's an element, 0 oxidation. Then next things I look for is binary ionic compounds, because you know the oxidation number is the charge. Okay, that's there are none here. Then I do polyatomic ions and molecular compounds, but there are none there either. And what we got is we got those special cases of ionic compounds with polyatomic ions in it. So therefore, to figure this out, I would break it up into ions. I know this is copper plus 2 plus, so it's plus 2. I know that's silver 1 minus, 1 plus. Silver's 1 plus. Then the nitrate, I would go and I'd see that oxygen is more electronegative than nitrogen, so it's a minus 2. So I'd say that 3 times minus 2 is minus 6, plus 1x, okay, is equal to minus 1. The whole thing is minus 1. So if you do the math, it's plus 5. So that's the oxidation number of N. And if you look over here, it's still nitrate, so the oxidation numbers are exactly the same. Okay, so therefore now I have all the oxidation numbers, and that's why you do you learn oxidation numbers. Now what you do is you look at the oxidation numbers and you determine if this is a redox reaction or not. If you don't have, again, the rule is one substance is going to be losing electrons and one substance is going to be gaining electrons. So they're going to have a change in the oxidation number. So you look for materials that change the oxidation number from here to over there. Okay, from the reactant form to the product form. You see that silver goes from 0 to plus 1 and copper goes from plus 1 to 0. There can only be one thing decreasing the oxidation number and one thing increasing the oxidation number. That's the only, you can't have any more than that. If none of the substance changes the oxidation number, like in this one, none of the oxidation numbers change, therefore it's not a redox reaction. Okay? Does it mean that there's not a reaction? No, it just means it's not a redox reaction. Okay? So therefore, that's the third step you're going to do. The fourth step is now you're going to start determining what's oxidized and what's reduced. So what you do is, like it says, is you make these brackets. This is why you need a little space above. There's one bracket always above and one bracket always below. And what you do is, for example, this silver goes from 0 to plus 1. And it's important to put the arrows pointing to just the silver. Okay? you make an arrow with a line to the other silver on the opposite side. And then what you do is, you don't have to write steps here, but then what you do is you write 0, the oxidation number as a reactant, arrow, meaning the reaction, to what the oxidation number is as a product, which is plus 1. And if you go from 0 oxidation number to a plus 1 oxidation number, you are losing electrons. Okay, how many electrons? We're not going to worry about that. We worry about that when we balance chemical reactions and we balance redox reactions. We haven't got to that yet. Then you go down here and you see that it's from plus 2 to 0, and that is gaining electrons. So, as you know, Leo the lion goes grr, losing electrons is oxidation. So if you go back up here, and that's why you write lose electrons, okay? And you can write the little e with a negative sign instead of the word electron. So what you see is the fact that that this silver, and again, you only write down reactant information here. So that silver, Ag0, is being oxidized because it's losing electrons. And GR stands for gaining electrons is reduction. So the Cu plus 2 is actually being reduced. Okay, and the thing that's being reduced and oxidized is only the substance. So the arrow is pointing to the thing you're drawing. So you see, it's not the whole compound here that's being reduced. It's only the Cu plus 2. Then the agent, to figure out the agent, the way I do it is, I know that the copper, the CO2 is being reduced. So what I do is I put my finger over this whole thing and I look at that arrow and I say, hey, who is helping this Cu plus 2 being reduced? Well, it's the silver, the thing on the opposite side of the plus sign. So therefore I write that. The same thing for what's the oxidizing agent. I know that this is being oxidized. I put my finger over that. I look on the opposite side of the plus sign, and it's the whole thing that's helping. So therefore, it's the whole thing, which is the oxidizing agent. And that's what? And that's the answers. And that's the answer they're looking for. The best way of writing the answers is you put lines in these words are exactly the same for every single problem. Okay? And then you fill in the appropriate information. And what you see is the thing that is being reduced and the thing that is being oxidized is always just a part, as in it's not the whole thing unless it's an element. And there are no coefficients any place, just in case the reaction is balanced. And the agents are always the whole thing. So what I tell my students is the fact that with the things that are being reduced and the things that are being oxidized, that's why your arrow is pointing to one thing, okay? In the agents, that's why I'm keying in on this plus sign, and I'm putting my finger, like what's the reducing agent? Well, the Cu plus 2 is being reduced, so I put my finger over this, I look at that, and I look at the guy next to it, which is the silver. For elements, you don't have to put the oxidation number here. Usually to make it easier for myself, what I do is here you always need oxidation numbers, and that's correct. It's wrong not to put them in. And over here, you never put in oxidation numbers because it's the whole substance. And that's a way in which I can differentiate the two. Okay? And that's how you determine which substance are being oxidized, which is reduced, which is the oxidizing agent, which is the reducing agent. Again, for this one, I did the same exact analysis, except when I get through all oxidation numbers of everybody, the Na has a +1 on the reactant side. It has a +1 on the product side. Cl has a -1, -1. Silver has a +1. Silver has a +1. N has a +5. N has a +5. O has a -2. O has a -2. So there are no oxidation number changes, so it's not a redox reaction. And again, that doesn't mean it's not reacting. It just means it's not a redox reaction. Okay? So I hope this helps you out in understanding, and that's what the rest of this handout talks about. Okay? Hopefully this helps you out in determining what's being oxidized and what's being reduced in the agents for a redox reaction. Thank you. And sorry about the announcement.